Black holes are not just objects in space. They are the closest thing we have to the edge of reality itself. Somewhere in the universe, right now, their gravity is so powerful that even light, the fastest thing that exists, can never escape. If you were to get too close, you wouldn't just die. You would be erased, stretched, broken, and lost forever to a place we still don't fully understand. But what exactly is a black hole? How are they created? And what really happens if something falls inside? To answer that, we have to start with something simple: gravity. Gravity is the force that holds everything together. It keeps your feet on the ground, the moon orbiting the Earth, and the Earth orbiting the sun. Normally, gravity is weak. You can overcome it just by jumping. But when an object becomes extremely massive and incredibly compact, gravity changes. It becomes unstoppable. This is exactly how a black hole is born. Every star in the universe is fighting a constant battle. Inside its core, nuclear fusion creates an outward pressure, while gravity pulls everything inward. As long as these forces are balanced, the star survives. But eventually, the star runs out of fuel. And when that happens, gravity wins. In a fraction of a second, the core collapses violently inward. The outer layers explode into space in a massive supernova, lighting up the universe. But at the center, something unimaginable is left behind. All that mass, crushed into an incredibly small point, a black hole. At the heart of every black hole lies something we call a singularity, a point where density becomes infinite, and the laws of physics completely break down. Surrounding it is the event horizon. This is the most important boundary in the universe, because once you cross it, there is no return. Not even light can escape from beyond this point, and that's why black holes appear completely black. But despite how they're often described, black holes are not cosmic vacuum cleaners. They don't go around sucking everything in. If our sun were suddenly replaced by a black hole of the same mass, Earth would continue orbiting it exactly as before. The difference? There would be no light, no heat, and life would slowly disappear. Black holes only become deadly when you get too close. And if you do, that's when things become truly terrifying. As you fall toward a black hole, gravity doesn't pull evenly on your body. Your feet, being closer, feel a stronger pull than your head. At first, you might not notice it, but within seconds, your body begins to stretch. Longer, thinner, until eventually, you are pulled apart at the atomic level. This process has a strangely harmless name, spaghettification, but there is nothing harmless about it. From your perspective, you would fall faster and faster, crossing the event horizon without even realizing the exact moment it happened. But to someone watching from far away, you would appear to slow down. Your movements would stretch in time, becoming slower and slower, until you seem frozen at the edge of the black hole. And then, you would fade away. This happens because black holes don't just bend space, they bend time itself. According to Einstein's theory of general relativity, the stronger the gravity, the slower time moves. Near a black hole, this effect becomes extreme. Minutes for you, could be years or even centuries for someone far away. Black holes are not all the same. Some are only a few times more massive than our sun. These are called stellar black holes, but others are far more massive. At the center of almost every galaxy, including our own, there is a supermassive black hole. In the Milky Way, it's known as Sagittarius A star. It has a mass of over 4 million suns, and it's sitting there, right now, holding our galaxy together. But black holes are not completely invisible. As matter falls toward them, it forms a spinning disk of gas and dust, called an accretion disk. This material heats up to millions of degrees, glowing brighter than entire stars. In some cases, black holes even launch massive jets of energy, shooting out into space at nearly the speed of light. These jets can stretch across entire galaxies. And yet, the black hole itself remains hidden in darkness. In 2019, humanity captured its first real image of a black hole. Using a network of telescopes across the Earth, scientists created a virtual planet-sized lens. What they saw was incredible. A glowing ring of fire surrounding a perfect circle of darkness, the shadow of a black hole. Proof that these objects truly exist. But even now, we still don't fully understand them. One of the biggest mysteries is what happens to information. In physics, information can never truly be destroyed. But when something falls into a black hole, it seems to disappear completely. So where does it go? This question has puzzled scientists for decades, and we still don't have a clear answer. Another strange discovery came from Stephen Hawking. He proposed that black holes are not entirely black. Due to quantum effects near the event horizon, they can slowly emit radiation. Over incredibly long periods of time, this means black holes could actually evaporate, disappear. But not anytime soon. The largest black holes would take longer than the age of the universe to fade away. Some theories suggest something even more extreme, that black holes could be connected to wormholes, bridges linking distant parts of space and time, or even gateways to entirely different universes. These ideas are still theoretical, but they show just how strange black holes really are. They are not just objects. They are boundaries, limits, places where our understanding of reality begins to fail. And maybe, beyond the event horizon, there is something we have never seen before, something we may never be able to understand. Because once something enters a black hole, it is gone, forever. And yet, despite everything we've learned, one question still remains. What is truly waiting on the other side?